Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast we like to call Space Nuts for no other reason than it wasn't taken. And joining us as always is Fred Watson from the Australian Astronomical Observatory. Hello, Fred.
Hi, Andrew. Maybe it wasn't taken because nobody would be stupid enough to call the podcast Space Nuts.
Possibly not. Possibly not. I will say it was not my idea.
No, good.
But,
it wasn't mine either.
Anyway, we're stuck with it.
Yeah, I think we are.
Today, we're going to talk about something that I didn't know had happened in the history of space, or the space race, and I suspect you didn't know either, Fred, and not many people do. So we're going to look at the 50th anniversary of Australia entering the space race. We're also going to talk about China finding signs of dark matter. Well, they reckon they have, but they actually haven't seen this stuff. So, you know, come on.
That's because it's dark.
Yeah, well, whatever. And space pizza on the menu today as well. But first, Fred, 50 years since Australia entered the space race, the auspicious date of the 29th of November 1967. Now, you know me, I'm always looking for a reason to add an extra public holiday to the Australian calendar. Here it is.
Yeah, that's right. It's a no-brainer, really, isn't it? We should have a holiday every year on the 29th of November. And for the Scottish people amidst us, it would just give us a warm-up for the 30th of November, which is St Andrew's Day. So there you go. The story is a really interesting one, though, and I confess to my shame that I was not aware of this either, that on the 29th of November 1967, Australia became only the third country in the world to build and launch a satellite from its own land, from its own territory. So this is really, a surprising thing. We were up there with the Russians and the Americans, who were, of course, the other two. And it was a spacecraft that was designed by actually the Weapons Research Establishment, as it was then called. And so it was called RESAT, spelt with a silent W at the beginning, WRESAT, which is the Weapons Research Establishment satellite. It was a satellite designed to look at the upper atmosphere, to probe the environment above the upper atmosphere. In fact, the Earth's, the Earth's ionosphere, and above the radiation layers above that. But the extraordinary thing is, as I just said, it was launched from Australia, actually not using an Australian-built rocket, but it does turn out that we, at that time, probably had the technology to build our own rocket to carry this up anyway, because Australia had already built what were called sounding rockets. I think they still are. There's a very famous one that was used many times, or the design used many times, called the Blackbird, a British sounding rocket. And I think Australia had equivalents. So we could have built the rocket, but we didn't. The rocket was, I think it was a Redstone rocket that became available by the US. It was surplus to their requirements. And so they asked around, anybody want a rocket?
And how Aussie is it for us to say, oh, look, we could have done it ourselves, but that one's really cheap. We'll use it. Just, refer to car industry. But that doesn't surprise me in the slightest.
Yeah, well, that's right. There are parallels there, definitely. Anyway, we got this rocket, and the satellite was designed by the Weapons Research Establishment and built by them, and then launched from Woomera, from the what was the rocket proving ground in Woomera, and successfully put into orbit. I think it was in orbit for a number of weeks. 8 weeks is the figure that comes to my mind. I'm not sure whether that's accurate, but it was about that length of time before it re-entered the atmosphere. And the rocket itself is still around. It's actually preserved, I think, at Woomera. I should check that, but I think you can go and see this rocket. Yes, the Woomera Heritage Centre Rocket Park
Well,
has this rocket. Of course, the rocket body itself fell back to Earth, and basically is not in good shape because of that, because there was no steps made for it to fall back to Earth in a controlled manner.
we couldn't afford the silk.
Yes, that's right. Parachute. We had to borrow that as well. Yeah, actually. So that, yes. So it's an amazing story. An Australian launched spacecraft, only the third country in the world to do that. Why do people not know about this? Why didn't I know about it?
Well, that's the obvious question, which I was going to pose, but now that you've opened that door,
Yes.
why didn't we know about this, Fred?
I think it's there has been a suggestion. There's a very nice article about this by Alice Gorman, somebody I know from her outreach activities in space and astronomy. Alice is actually a space archaeologist. She's a really interesting character to talk to, because she's all about the heritage value of orbiting spacecraft and things of that sort. But she's written a very nice article that kind of begs the question. Is it because of the tall poppy syndrome? Is it because we in Australia are always, we're always kind of suspicious of anybody who sticks up above the crowd and says,
puffs themselves up a bit. It's true.
So maybe we just say, we launched a rocket.
We did that. Yeah, been there, done that. What's next?
No, really interesting. Alice actually, in her article about this, makes the comment that space was big news in Australia in the 1960s, and of course it was everywhere because of the Apollo program. But a lot of things that would have suggested that people would have made more of this weapons research establishment satellite, and I think it makes me wonder whether that sort of military research connection was seen as its downfall in terms of public image, that it was just too close to the Vietnam War and all that sort of thing at a time when Australia was perhaps looking away from strong military connections. Maybe that something to do.
Right in the middle of the Cold War, and
yes, that's right,
all that sort of stuff. So it also proves why we weren't that shocked by Star Wars. I mean, if we were getting involved that early, it probably wasn't that big a shock to us. I'm looking at a photo, Fred, of a piece of space junk which has got USA painted on the side, lying on its side behind a chicken wire fence. That wouldn't be it, would it?
It would, yeah. And
gee, we're good at putting things on display in this country. I mean,
what's wrong with chicken wire?
They've spared no expense.
Alice again points out that because this thing got hot as it re-entered the atmosphere, it wasn't coming in fast enough to melt, but it got hot and it burned off the kangaroo that had been painted on the side of it and revealed the letters USA underneath. Because of course,
is that what it is?
Yeah, and you can sort of see traces of something that could be a kangaroo behind the chicken wire there.
I can too, but it doesn't surprise me, and we're pretty good at killing kangaroos in this country too.
Yeah, that's right. We are.
But look, for all jokes aside, it's a really impressive achievement and one that's gone mostly unnoticed. And we should be kind of proud of ourselves without getting too puffed up and turning ourselves into tall poppies.
I think they need to make a movie about it, Andrew.
They should.
A bit like The Dish.
Well, that was a huge success. Great film. And again, another example of Australians paying themselves out.
Yes.
Which we're very good at doing.
Yeah, that's right.
Very good at doing. And if anyone ever gets a chance to go to Woomera, or as those UK kinds of people like to call it, Woomera, it's in South Australia, which is where you are, Fred, at the moment.
Indeed, although I'm not at Woomera, I'm in Adelaide. I'm just proving the point for you.
And for those who are wondering what Woomera means, especially those that aren't from Australia, a Woomera was an Aboriginal weapon which they used to launch spears so that they could actually throw them much further. They had a lever effect. They could fling a spear a lot further and a lot faster using a woomera, and that's why our rocket range has that name. You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and team with a go.
Space Nuts.
Now, Fred, one of the, I suppose, pet subjects in astronomy at this point in time, and that is dark matter. It's something that we think exists. It's something that I recently read where they suggested, no, hang on, no, it doesn't. Well, now the Chinese say, yes, it does. We've found evidence of it, except they haven't seen anything. So where are we at?
It's the blind leading the blind, really, isn't it?
A little bit.
Yeah. So dark matter 101, we know it's there because we see the effect of something that has gravitation, but is otherwise invisible, holding galaxies together. So when we look at galaxies in space, we can measure how fast they're rotating, these huge aggregations of hundreds of billions of stars and gas and lots of dust and things like that. The way they spin, they should fly apart, because when you look at them, there's not enough matter in them to have the gravity required to counteract the centrifugal force of the spin. But they don't fly apart. They last for a very long time. Many of the oldest galaxies have been around for 12 or 13 billion years. So that led to the realization, principally in the 1980s, although there were hints of it 50 years before that, the realization that there is something out there which has been misnamed dark matter. It really should be called invisible matter. But there's something out there that doesn't have any kind of interaction with normal light or normal matter, except that it has gravitation. And so that's led the people who build theories about subatomic particles, that's led them on this really, I guess it's an epic trek to try and work out what these dark matter particles are. And I might just add here, Andrew, that the idea that dark matter was actually things like failed stars or small black holes or dead planets or whatever. In other words, solid things that you can't see because they don't radiate anything. The idea that dark matter was made of those was scotched in the 1990s because we found evidence that actually that's not the case. And so dark matter is now known to be some species of subatomic particle, kind of like the electrons and protons that we're used to making up normal matter, but much more massive probably, and also with different characteristics that allow it to be revealed only by gravity. So that's the backstory. And now there is a front story as well, because some of the theoretical models of what dark matter is suggest that you can get a situation where very rarely a dark matter particle will hit a particle of normal matter and will split it into an electron and a positron. In other words, it'll basically hit the normal matter and turn the dark matter into its normal matter component and what we call antimatter, which is just the same thing but with a different electrical charge. So like an electron has an antimatter equivalent, which instead of having a negative electrical charge, which an electron has, it's got a positive electrical charge, and it's called a positron. And as everybody knows, if you bring a particle and its antiparticle together, like an electron and a positron, you'll get an emission of energy. You get energy out of it. It's a big thing in science fiction, having antimatter drives. I'm sure you know all about...
Absolutely, and positron ray guns.
Exactly, all that stuff. So there is the possibility that these dark matter particles rarely might hit a normal matter particle in such a way that it splits it into its particle and antiparticle equivalent. And if they do that, when those two recombine, you actually get basically a gamma ray signal. And that's one of the things that people have looked for around the centre of our galaxy, where there should be a lot of dark matter, because we believe dark matter is more common near the middle of galaxies. People have looked for evidence of particular kinds of gamma rays. Gamma rays are very short wavelength light rays. They're very high energy. So there have been hints of that, but this is slightly different. This is an experiment which is led by Chinese scientists, and indeed they have built a spacecraft whose name is DAMPE, D-A-M-P-E, which stands for Dark Matter Particle Explorer. And what that does is looks for particles flying through space. And in particular, it looks for what are called cosmic rays. Now, cosmic rays are raining down on the Earth all the time. They don't come from the sun. That's the solar wind that comes from the sun. The cosmic rays actually come from highly energetic events like supernova explosions and things like that in galaxies and in our own galaxies. So they are kind of there all the time, and some of them have got very high energies. So what this spacecraft is looking for is looking at the sort of cosmic ray background, this rain of cosmic rays that's coming in. But it's looking at a kind of spectrum of cosmic rays, with different energies that they have. So it's almost an equivalent in particle physics of what we do in light with a prism. You break up the light with a prism, and the high energy end is the violet end of the spectrum, the low energy end is the red end of the spectrum. You can do the same thing with particles. You've got a high energy end of the spectrum and a low energy end of the spectrum. You do that, and what you expect to find is a smooth curve, a smoothly varying curve that shows, that the energies peak in the middle or something like that and smoothly fall off on either side. But it turns out that you don't find that. You actually find a jump in this spectrum. And the particle physicists are convinced, or some of them are, that jump is because of interactions with dark matter particles. It's something happening with these cosmic rays that they bash into a dark matter particle, and the cosmic rays kind of split into bits, and so you get a characteristic point in this spectrum where something is missing. And that's what this spacecraft has found. It's very esoteric stuff, Andrew, and I'm certainly not explaining it very well. But the suggestion now is that we're perhaps seeing the first evidence of a real detection of dark matter rather than just a detection because of its gravity. There's clearly going to be more exploration of these data. They will analyze the results to bits, and I think the spacecraft is still active. It's still doing its thing. So I think this is one of these news stories that we need to watch. That we might find that the swell of scientific opinion moves towards the fact that yes, this was genuinely dark matter detection, and that would be very exciting because it gives us an idea what to look for when you're trying to create an equivalent of all that in machines like the Large Hadron Collider down there in Geneva.
We probably shouldn't be surprised that it's panning out the way it is, because how many discoveries in astronomy have been made by putting together concepts that you can't see, resulting in a detection of some kind that suggests, okay, something's out there. I mean, they use mathematics to find objects they know exist but have never seen. So
yes, that's right.
It stands to reason that this is a very big step forward in seeing dark matter, or at least proving its existence.
I think that's right.
Beyond reasonable doubt.
That's correct, yeah. And so, well, I guess we can all hope that it won't leave us in the dark for much longer.
Well, it doesn't matter.
Touché.
All right, we'll leave it there, but there'll be more on dark matter, I'm sure, in the not-too-distant future.
That's
You're listening to Space Nuts. Andrew Dunkley here, and Fred Watson somewhere down there on the bottom of the Australian continental shelf.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, never let it be said that we don't take this show deadly seriously. I mean, we've talked about some incredible stuff over the last couple of years, and just reflecting on other things we've talked about in recent times, such as animals in space. You know, there've been rats, mice, chimpanzees, dogs, and even spiders in space. But now we've got pizza in space. It doesn't get any more serious than that.
Well, it doesn't if you're a pizza lover and you're stuck up on the International Space Station for 6 months wondering when you're next going to get a pizza. I think this is deadly serious, Andrew, and clearly NASA has taken it seriously enough that a specially designed pizza oven for use in zero gravity has been flown to the International Space Station with the latest set of cargo that's gone up there. So yes, we've seen some lovely video footage now from the International Space Station of astronauts feasting on pizzas, and actually, it's even worse than that because. Just as we are told when we're from infancy that you don't play with your food, that's actually what they're doing.
Yeah, they are. They're playing frisbees. They're doing that spin on the finger thing, which they're cheating because they're in zero G. That's cheating. And but it looks like they were having a hell of a lot of fun.
It does indeed, and they probably enjoyed eating it as well. I guess the question is, why is it hard to make a pizza in space? And I suspect also the answer lies in the fact that if you think about the way a pizza's made on Earth, gravity does play quite an important role.
It plays a huge role.
It sticks everything down. So I don't know quite how they managed to do it in space, whether they coated their pizza bases with some particularly sticky form of cheese that meant that when you put the various ingredients on it, they actually stuck there. They didn't just float away. But the end result is successful, as the video attests. They are certainly feasting on pizzas. And I bet the smell throughout the space station was pretty good.
Yeah, well, from what I've heard about the space station and spaceships in general, the smell on them is usually pretty bad.
Yeah,
so maybe a little hint of pizza sauce, pepperoni, anchovy. No, let's not go there. It would probably, lighten the atmosphere a bit, so to speak.
I guess it might have done. This story has echoes of another story that I think we covered a couple of years ago, which was about an Italian astronaut who did her stint on the space station. Sadly, I can't remember her name, but I'm sure I could find it very easily. But a part of the deal when she went up into space was that a very well-known Italian coffee-making company developed an espresso machine that could work in zero gravity, so that she could have a cup of coffee every morning. And they sent it up as well. When she flew, this espresso machine was sent up to provide her needs.
Was it Samantha Cristoforetti?
There was a C in her name. I do remember that.
Yeah, yes, because I just looked it up.
Right. I thought your memory was pretty good there, Andrew, but I should have known better, really.
Yeah, you should have.
But don't play short.
How much would a space pizza oven actually cost? Now,
I don't know. It's a good question. Most things that you send up into space are specially made, so they cost rather a lot of money. But if you could find a way of 3D printing one, then it'll be a lot cheaper.
Yeah, that's an interesting thought. And of course, these days we do enjoy home delivery when it comes to pizza, but I would imagine that this home delivery cost a heck of a lot.
It could have done, yes. Well, especially if the home delivery included the oven that you make the pizzas with. Yes. More than the usual remit.
Oh, I wouldn't pay for the delivery if I had to cook it myself.
Yeah, quite so. Anyway, hopefully these people on the space station enjoyed their meal of pizza. I think Samantha, who you mentioned, enjoyed her coffee as well, except there's a slight touch of ignominy about it, because you make this beautiful espresso coffee, but then you've got to drink it through a straw, because the only way to get it into your mouth.
It's no way to drink coffee.
No, that's right. It's not really.
But they actually did eat the pizzas like you'd eat a pizza. So
I think
they had that advantage.
When they managed to catch them.
Yeah, that's right. And if you do want to watch the video, I think you'll find it on the BBC Science and Environment webpage. So worth having a look. It's only a short video, but what they didn't, it's in high speed, so you can see the whole process in lightning speed in about 45 seconds. The only thing they needed under that was some Benny Hill music, I reckon.
Quite so.
Would have finished it off nicely.
Indeed it would.
We will leave it there. Fred, thank you so much as always. Enjoy Adelaide, and I'm sure you can't wait to get back to New South Wales.
I'll probably find my way back there eventually, I hope. Anyway, good to talk to you again, Andrew, and we'll speak again soon.
That's Fred Watson from the Australian Astronomical Observatory even, and you've been listening to the podcast we like to call Space Nuts, with traces of Andrew and Fred. And you can listen online anytime through most podcast distributors. Don't forget to listen to back issues. This was episode 82, so we've been at this for a very, very long time. But we have a lot of fun, and we hope you do too. And we love your feedback via Twitter and Facebook, so please keep those comments, questions, ideas and concepts coming in. Until next time, thank you again for joining us on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.